Okay, so hi everyone. I'm Yuqing from Peking University. So I'm very happy to announce that this is session, Women in Econ CS. So I actually chair this session, organize this session with Professor Xu Jingchen and Pingyan Lu. And I'm very honored to be the first speaker today in this session. And from today, I think we're going to have serious talks by several female researchers in this area and around the similar time. Okay, so I'm very honored to be the first one. So today I'm going to share with you about my work about how to elicit information by information theory. Okay. So my work actually focuses on how to cross out subjective opinions. So like in the peer review setting, we need to cross out subjective opinions about the quality of some assignments. And also like in the scenario of the products evaluation or art evaluation, we also need to collect subjective opinions from the crowds. And the point of this scenario is that the opinions we actually collect is actually unverifiable because it is actually subjective. So in other settings, the opinions we collect may not be subjective, but we cannot verify it. And election polls is also an example. Because when we ask them like, what's your intention for the vote, we cannot verify the answer we collect. And also it's about the forecast about volcano. It's like it is verifiable, but it's very hard for us to verify the answers. And the central question in this area is that when the information opinion cannot be verified, how can we incentivize high quality information? And how can we aggregate and evaluate the information? When this information cannot be verified. And this area is actually, this problem is actually closely related to the area called peer prediction, proposed by Miller, Resnick, and Zeckhauser in 2004. The central concept they raise for this area is that although the information you provide, I cannot verify it, but I can still reward you based on what you report and what your peer reports. And they actually propose the first mechanism that is cleverly designed how to reward based on this you and your peers report and has better properties than the classic majority votes. And another important work in this area is by Pretles. It's also in 2004, the Bayesian truth theorem. And I also list several great researchers in this area. And my work in this area, actually, I'm gonna introduce one general information theoretic paradigm I proposed with my collaborator. And all my work actually follows this paradigm. And I'm going to also introduce two concrete examples using this paradigm. So the idea of this paradigm is actually, at least natural to me, is how can we incentivize the high quality information? So we're gonna reward each person based on the amount of information we measure. And also we're gonna return, when we need to aggregate the information, we're gonna return the most informative answer. And then you may ask, like, what does information mean? How can we measure the information? So conceptually, the information just means the structure of the cross-source data. So basically, when we get the when we collect the data from the crowds, so we may need to do some structure recognition thing for the data. And at a high level, we think the informative data has a lot of structure, and the uninformative data doesn't have any structure in it. And what we want is like, we want a structure recognition method such that we can recognize the structure without any ground truths or gold standards. And also we want this structure measure has some monotonicity property. So basically, if we perform some meanness operation on the structure, it becomes less structured. And from information theoretic language, we actually want an information measure, which we can measure the amount of information without verification. And also it satisfies the property that if we perform an uninformative operation, this object going to become less informative. So why we want an information measure to satisfy this property? Because use the conceptual paradigm I told you before, we can then with this information measure, we can reward the person based on the amount of information he or she provides. And in such case, this reward system will incentivize them will discourage them to perform any uninformative strategy on their report because it will lead to less reward. And with this information measure definition, we can also construct a scoring system such that we're going to evaluate each person using the information measure to measure the amount of information of her report. And then with proper definition for expert and non-experts, this scoring system will have the property that the score of the expert is going to be greater than the score of the non-expert. Okay. So basically, the point of these previous slides show that we can distill this cross-sourcing unverifiable opinions question to the question of how can we design proper information measures. Okay. And this is the basic framework here. So we will query the information from the crowds properly. And then after we collect the data, we're going to do some structure recognition approach. And then we're going to use this amount of structure, in other words, amount of information to give them proper reward and also get a proper aggregation. And here I'm going to give you two concrete examples for this paradigm. So the first example here is like we have several participants. They're going to be asked to, like in this example, we have two participants. So they're going to be asked they're going to be asked to evaluate several fruits, and they will tell us whether they like the fruit or dislike the fruit. And this setting is actually proposed by Descoupte and Gauche in 2013. And the goal in this setting is we want to design a proper reward to encourage truth telling. And you may ask, like, why can't we just reward these two people by the number of agreements they have? And because in this case, both of them gonna see like for everything to get the maximum amount of a reward. And here is a mechanism I propose this year. So basically, we will ask these two people like several questions, like 5 questions here. And we're going to divide these questions into 2 question batch. And for each batch, we just count how many people like the, how many fruits they both like, and how many fruits they both hate, and how many fruits one like and one dislike. And in that case, we will get this counting matrix. And for each batch, we will calculate the determinant of this counting matrix, and then the reward will be the product of the 2 determinants. And so in this case, we can see that these 2 people actually have negative correlated tastes to each other. If we pay them for agreements, they will get less reward, even they tell the truth. But with this determinant-based rewards, although they are negatively correlated and in both the determinants has negative values, but the product of the determinant actually being positive. So intuitively, it is kind of a reasonable payment method. And let's go back to the previous paradigm I mentioned to you. Is like why this reward system does some structure recognition. So the structure it recognizes is actually in the right. So when the counting matrix of their report has this like very modular format, like the perfectly positive correlated or perfectly negatively correlated. And in such case, when they have this kind of structure, they will be rewarded a lot because the absolute value of the determinant is high. And in the left case, if their report actually has no relation, it's like independent of each other. And in that case, there is no structure in the counting matrix, and they will get nothing here. So, and also this determinant-based structure recognition methods satisfy this monotonicity as well, because when one person performs some strategy, and in that case, it's like in this case, it's just like you multiply a matrix to the original matrix when they tell the truth. And in such case, it actually decreases the amount of structure contained in the matrix, and they will get less money. And in that case, we actually have can prove several good properties of this mechanism. And first is that it is no matter given so no matter what other people play, as long as the information they provide has some amount of information, and in that case, if you tell the truth or perform some other strategy that is equivalently informative as truth selling, and in that case, it's gonna be strictly better for you than you perform any other strategy. So another good property of this mechanism is that it is prior independent. It doesn't need any prior knowledge, and it is also practical, and in the sense that the implementation of this mechanism only require each participant to answer at least 2 C questions. So C is the number of choices. So in the binary case, in our running example, they only need to answer 4 questions. So this is actually the biggest improvement of this work. But the point I want to make here is that it still follows from the information theoretic paradigm I mentioned before. And this is kind of the overview of this mechanism. So we ask people several questions, and we try to recognize the modularity structure within their, so we transform their feedback to a matrix and try to recognize the modularity structure within the matrix using determinant, and then we reward them based on the amount of structure they have. Okay. So another example I want to show you is in this continuous setting, is like still they are asked to answer several questions, but like for example, they asked to predict the outcome of several games like the soccer, the football, and basketball, and each of them needs to report their prediction of like whether the green teams win in the end or the yellow teams win in the end. And it's different from the previous setting just because their answer is actually continuous, because they answer the probability. But we still have the same goal here, and we have this same challenge here. Like if we only pay them for agreements, they can always predict the same thing all the time. And in this case, we cannot use the previous determinant method here, because if we use their report to construct a matrix, it's gonna be infinite dimension. So in this case, we use another way to recognize the structure. So here, the idea is that when they tell the truth, they will be agree for the same computation they predict, but they will be disagree for the different games they read. And in that case, we are going to pay them according to this, like, so we're going to reward them for their agreements for the same game, and we're going to punish them for their agreement for different games. Okay. And within this method, we can see that if they always tell the same thing in the left side, they will have perfect agreement for the same game, but they will also have perfect agreement for different game. And in that case, this structure actually is meaningless. And because of the design of the rewards, they will be paid nothing here. But in the organic case, when they actually tell the truth, it naturally has a property that with some probability, they actually disagree with each other for different games because it actually are independent games. And in that case, they will be paid a lot compared to the left case. And it also satisfies the monotonicity here. Like, for example, if one of the participants performs a strategy like she will when she thinks the green team is gonna win with probability greater than half, she will report 100. And when she think the green team gonna win with probability less than half, she gonna report 0. So with this strategy, so she although she may increase agreement for the same games, but she will also increase the agreement for different games. And with proper math, we can prove that this will also decrease the reward in total. And this is the property of this continuous setting. And it is actually a little bit worse than the discrete setting, because in the discrete setting, they are just as a simple multi-choice question like A, B, C, D. But in this continuous setting, their answer space has infinite dimension. So we can only get the property that everyone tells the truth is the optimal strategy profile, and the whole implementation of this mechanism is almost prior-independent. So basically, we need to assume that the two participants in our mechanism actually has like conditional independent information structure, and it is different from the previous discrete setting. There, we do not have any assumption there. Okay. But the point is, it still follows from the conceptual paradigm I mentioned you before. We ask them several questions, and we kind of doing this structure recognition thing from their reports, and then we use this structure recognition to design the information measure and to give them proper reward and aggregation. Okay, so that is kind of all about the thing I'm going to tell you today. So this information theoretic paradigm actually illuminates the work of the challenge from information elicitation to the information measure design problem in information theory. And also these two examples I show you follow this paradigm. And also, currently, I actually work on, with my collaborators, we actually work on several more general settings. And in these general settings, we actually have very different definition for how to define the information structure, how to define the structure recognition methods. And I'm hoping to share with you later, maybe next year. And thanks.